Hi, my name is Augustia and I'm a rising sophomore and part of the Northview Aerospace Society. We recently were chosen as national finalists for the American Rocketry Challenge, chosen among the top 100 out of 1,117 across the country. That places our club and our school among the top 9% in the country. We could not have achieved this without all our members who each played a vital role helping us qualify for the national competition. Here's exactly how we did it. We started off last semester, fall 2025, planning out our timelines, deadlines, and model rocketry plans. We started off by carefully reading through the American Rocketry rules and team manual, eventually learning how to build an effective rocket using resources online. As a beginner team, we were still seeking some guidance. We reached out to Makeo, who led Boy Scouts Troop 74 from New Jersey to a first place finish at the American Rocketry Challenge Nationals held last year. His advice on build parameters, timelines, and materials evaluation was invaluable. From here, we were confident in taking a shot at designing our own. The first step was designing a rocket in OpenRocket, a free software that allows you to design and simulate the fundamental structure of your rocket. We are aiming to be as close to the American Rocketry Challenge's flight goals, with an apogee or max altitude of 750 feet, a flight time of 36 to 39 seconds, and the safe return of a payload, being an egg. During my design process, I started off with the basic design requirements, like the minimum length and width of the rocket specified by the challenge, egg size, and the size of the tubes we could use. Then I played around with the shape of the fins and nose cone and the motor we would be using until I got the right apogee and flight time in the simulation. Through tweaking throughout the year, we landed on our 2026 design that eventually flew us to the American Rocketry Challenge Nationals. We could now start with the build process. Michael and I designed the necessary 3D printed parts in a CAD software called Onshape. The parts were mainly printed by Michael's fast 3D printer out of PLA, with more heat-sensitive components printed out of PETG. While this was happening, we started the rocket assembly. After purchasing our rocket parts from SD's, Aeroflight, Perfect Flight, Aerotech, and local hobby stores, we were ready to build. We held club-wide build sessions, but during our designated club meetings and outside of schedules on the weekends. Ruhan cut the fins with a 3D printed stencil to get the most accurate dimensions possible. We measured and cut the tubes to their correct length and used a 3D printed bulkhead and nose cone to fill in the gaps. We epoxied the fins to the bottom tube using a 3D printed fin jig. We researched how to connect the parachute to the rocket using a shock board and the parachute's ideal placement within the rocket. Once the rocket was built, we painted it with our club's signature navy blue and it was ready for launch. Rishi and Michael launched a rocket at Collie Creek Park. We sent a final qualification flight to the American Rocketry Challenge and eventually received the news that we had qualified for the national competition. We are proud of the work each and every member contributed this year. We learned a lot about how to build, evaluate, and launch quality model rockets and had the most fun while doing it. We are looking forward to another ARC challenge next year, hoping to apply and grow our knowledge to perform even better.